It's great to be here. First time to Istanbul. Didn't have a lot of time, but yesterday I walked down to the waterside. I'm so thankful to be here and hope to be back with some more time in the future. Okay, so I'm going to talk about these 4 projects. You can already see the slides online if you're interested. You can follow along if you want. So what are these 4 projects about? The OpenJDK, which is the reference implementation of Java, is developed, is evolved with two different levels. One level is the projects, where somebody has an idea, which is probably like a more complex and longer ranging one. And so it puts together a couple of people, talks about that, and then you get one of these projects. And then they work on something, and the result of that is often what's called a JEP, a JDK enhancement proposal. And that means they're going to make a specific proposal. This is how we want to change the language or an API or whatever. And so if you look at these 4 projects, you will see how Java is changing right now and how that will impact what Java looks like in the future. So that's what I'm going to want to show you today, what these 4 big projects are going to be doing. The issue with that is that Project Valhalla alone, somebody just once joked that this is like 6 PhD theses. So doing some quick math, we have like 24 PhD theses ahead of us. That's more than 1 every 2 minutes. So we have to hurry. That also means I cannot give you like a detailed tutorial on these. You cannot just go home and use all of this. A, because much of this is not there yet. And B, because it will just be a surface level introduction so you understand where Java is going. So it's less about all the details, it's more about the direction this is taken. Okay, so let's start. We're going to start with Project Amber, which is focused on smaller productivity-oriented Java language features. And the idea is to tackle some of Java's downsides. Java can sometimes be cumbersome. Sometimes you need to have a lot of boilerplate in there to express something. And the reason for that is that Java in some situations lacks the expressiveness to give us the chance to just say what we want to say succinctly. And Amber wants to improve that. And unlike the other projects, Amber is not so much a solution to a problem, it's more like a solution factory. So Amber is going to do a couple of these things that I'm going to present now, and then after that, there's probably going to be other things, other rough edges of the language that could be improved. And it's going to look at those next. So this is not really like a project with a fixed endpoint. And it already did a bunch of things. Unlike all the other projects here, it already delivered a bunch of things that are already usable in production. So starting at the bottom with local variable type inference with var, and then we have a bunch of stuff here like switch expressions and text blocks. And a big chunk of that is pattern matching. So sealed types, records, type patterns, and switch expressions, those 4 together form the basis of pattern matching. And what I could do now is I could go into that. I could talk to you about pattern matching, but I'm not gonna. I'm going to have a talk there later that you can look if you're interested in that. I've brought you something else, which is unrelated to pattern matching, but something that Project Amber is also looking at. Okay, so what we're doing here is we're trying to put together a string, right? I have this SQL query here where I want to select from a table, but the property that I want to check by and the value that I want to compare by, those are both variables. So I want to embed these variables in a string. And these are like 2 ways to do that. They're both not great, but they work. And they come with a free SQL injection to boot. Why is this so cumbersome? Shouldn't this be easier? I mean, yeah, it could be easier. This is something like this. It's what many other languages allow, where you just embed this here. So the syntax highlighter doesn't understand this, of course, because this is made-up syntax, basically. But this would be a reference to the variable property, and this would be a reference to the variable value. And then you could be much faster with creating SQL injections. So that's still not great. I mean, that's what many other languages offer. So this is not just about SQL either. In general, when we produce strings like this, we're usually not producing, like prose, like error messages or log messages. Most often it's structured content. It might be HTML, JSON, XML, YAML, whatever. There's tons of different text-based formats, and usually we're producing one of those. And the issue with that is that they all have format-specific rules that you would have to check to make sure that you don't get stuff like SQL injection attacks. And so what Java is probably going to propose, there's a draft for this JDK enhancement proposal, it's going to look like this. So here I used text blocks, which have been standardized in Java 15, but this could also be just a single line in string in one line. I just did this because it formats a little bit nicer. So what I'm doing here is I once again use this syntax that may be the one that turns out to be where property and value reference the variables that are somewhere above here. But the interesting bit is that I have this str dot before. So these are like two different things that are going on here. One of them is I can now embed these variables here, and what I get is a called template string. but then I have a policy, and that policy takes that template string and turns it into a string. There's a small asterisk behind the string here. We're going to come back to that later. So one thing that I could do is this. I have a description, I have a price, a quantity. I'm creating something like a payment slip here, right? Where I do some easy math here. I could probably embed expressions here, not just variables. And this is the result that I get. But looks fine. This str policy simply just concatenates the values into the string. And you get this, which is a bit weird. Usually we don't pay like fractions of a cent. So there's room for improvement. Or we could have another policy. FMTR is another policy that does something else. What this one does, it accepts all of these formatting strings that that string.format understands as well. And that way we can fix this problem, and now we get like 355 here for the tax instead of a fractional cent, which is better. But so far we've just talked about strings. Now let's take a step back and think about that. Because I said earlier that often we want to create something like XML, JSON, SQL. But what we do is we have a string, we have some values, we put that together into probably the dumbest data format there is, which is a string, and then later we take it apart again and try to turn it into something meaningful, like a statement object or a JSON object. Well, you know what I mean, right? So I want to take this the string and parse it into something that we can work with. So why do we do the detour and go to string first? Well, at the moment we don't have a choice, but we could have a choice. And this is what the policy that I talked about, that string and this str and this fmtr are going to implement. This is the interface for that. And the really cool part is, you see it gets the templated string, but it returns a result. And that result can be of any type. So the proposal would probably be, let's not just take templated strings and turn them into strings. No, let's take templated strings and turn them into whatever we need at the moment. So for example, there could be a SQL policy, which does not have to necessarily be on board. It doesn't have to come with the JDK. This is something that we will probably be able to provide ourselves. And then we have this policy here that takes this string and it does what SQL needs to do, right? It checks that there is no injection, that it's a proper statement, all of that. It can do all of that and can give you back a statement. So you don't even go the detour, you just immediately parse this into the higher level object that you want to work with, instead of first dumbing it down to a string and then parsing it later back up. And the same you could do with JSON. If you do this, you have a JSON policy here that gives you a JSON object back. I think this is really powerful because it makes this feature much more widely applicable and also makes it sure that you can use it safely and don't make the easy thing, or rather make the wrong thing easier, by just making it easier to put strings where they're not so, like to put user data, for example, or strings somewhere where they're not escaped. We've all seen the log4 shell thing. Something like this could have prevented it. Or at least, yep, if well used at least. So template strings in a very early stage. It's not even a JDK enhancement proposal. It's just a draft that's even earlier, right? So all of what I just said can potentially change. I don't think it's very likely, but it can. And as I said, Ember does a bunch of other things too. So Ember is at the moment working on finishing pattern matching. This is the third preview in JDK 19. And it's looking good. I'm somewhat confident that it will be finalized soon. And then we have more stuff that we want to do. We want to add more patterns. There's like, at the moment, there's only type patterns. There's going to be record patterns, array patterns, maybe custom patterns. There's a bunch of things that could be happening. There's a JEP draft for concise method bodies. I'm not going to go into that here. And maybe serialization will get a revamp, which terribly needs. There's a white paper for that, which is even earlier. So it's more like a rough outline of an idea. That will surely take a couple of years before we see any of that. So Project Ember wants to make us more productive by making Java more expressive. Basically, that's like the through line here. Now, you could ask when all this happens. If you're like me, you want to know when do I get to play with all this good stuff? Now, if you ask my colleagues, or I didn't mention that, right? I work at Oracle. So if I ask my colleagues, when will all this be done? They're going to say, when it's ready, which is, that's the only good answer you can give, really, but it's also a very boring answer. So what I do instead is, I don't ask them this question because I'm only going to get boring answers. Instead, I'm going to make my personal guesses. So I read the mailing lists, I read the JEPs. These are my guesses. You cannot sue Oracle for this, and you cannot sue me because I don't have money. So my personal guess for the timeline is that deconstruction, well, the first one is not a guess, actually. Deconstruction patterns will preview in JDK 19. That JEP has been targeted just a week ago or something, which is pretty good. And then I'm pretty sure that next year we'll see patterns in Switch finalized, and then finally we have everything together to start using pattern matching in practice. I'm pretty sure that templated strings, we'll see that next year at some point, and then after that, Amber will find more things to do, but one thing that I already know is that we want to have more patterns, as I mentioned earlier. So all of this is, at this, like, Amber's like in the middle, it feels, of bringing us new stuff. As I said earlier, I'm going to give you more links. If you're interested in any of these specific projects, and you look at the slides at the bottom of each project, there's always a list of these links, and the talk, for example, if you're interested in pattern matching, would be this one. It's a presentation I gave at Oracle Dev Live. Some of those videos feature me, some of them feature other people. And then also at the beginning, I usually have like a design document, because most of these features have design documents, and I can only recommend reading them. Okay, let's take a step back, and let's do something else. Project Panama. Totally unrelated. It wants to connect JVM and native code. Once again, there are all the links here if you're interested in any of these projects. And this ran since 2014. And it can be roughly divided into 3 sub-projects. The vector API, and then foreign memory API and foreign function API. Although the bottom 2, they are strongly connected. Let's talk a little bit about vector and vectorization. So I have like a very simple problem here. I have 2 arrays, A and B. And they have to all have the same length, but let's assume that's the case. And I want to do this computation. I want to square each number in A and add the number in B, and then they take the negative and then compute that to C. So I have like one array and another array, and then for the result, I want to pairwise always create this computation. So this implementation of this is very simple. I just loop over the arrays, and I do the actual math here, and then I'm done. That's pretty straightforward. Now the thing here is that this code works and is correct, but it could be much faster, because modern CPUs have so-called multi-word registers. So they don't only have to add like one float and another float and add them. What they can do is you can give them like 16 floats and 16 floats, and they add them to 16 results, and that takes about the same amount of time as a single addition. This is not parallelization. You're not doing this across different cores. It's just one core that can do this much faster. That's, I think, like the Intel MMX extension back in the days was the first one to make this popular, or at least was one that made this popular. So this laptop here, for example, has 512-bit registers, so it could indeed compute 16 pairs of floats to 16 results. And this is called single instruction, that would be the addition, and multiple data, that would be all of those floats. So SIMD is the shortcut. And the just-in-time compiler knows about this, and it tries to optimize for this. It tries to see, oh, this is a loop, and if I just unroll this, meaning if I just don't have like a loop that goes in steps of 1, maybe I have a loop, I turn into a loop that goes in steps of 32, so I have like 32 times the same command, and then realize, wait a moment, I can like group them together. It does that, but it's not terribly reliable. So it's good to get like a performance boost without knowing about it, but you cannot rely on this if performance is critical for you. And this is where the vector API comes in. The vector API basically says, look, let's try to make this reliable. Let's give you an API that you can use, that you can always hit this vectorization, or rather this vector support in your CPU. And this looks way more complicated than the other computation, but you can see most of the critical parts here. So let's ignore whatever a species is. You start with a loop that looks slightly different, but you still more or less go over the same arrays. And then you take array A and pull out a vector of A. Then you go to array B to pull out a vector of B. You do the math here, A times A times A, B times B, you add those up, you take the negative. That's like big integer math. That's always fun to write out arithmetics with method calls. And then you write the result into the array C. So this does the same computation, but in steps. Each of those vectors will have some length. You don't know it when you write this code, which length this has, because this will happen when the just-in-time compiler kicks in. So this API is clear and concise, given the requirements, so it's not like you can look at it and be like, yeah, sure, that's what I would have written. But it does work really well. And the cool part about this are like the bottom 3. This is, you can write this code on Java and will run on every platform, whether they have vectorization or not, whether they have 512 bits like this one, or 256 like my Ryzen at home, doesn't matter. The just-in-time compiler will always figure out, while it's creating machine code, what CPU architecture you have, and will create the optimal code for that. And even if you're targeting a system that doesn't have vectorization, it will then create the code that does like the simple math that we saw before. So even if you target a system that doesn't have this, you will not get a performance hit. You will always have at least the same performance as today, but on most CPUs will be much better. So this is not a lack of daily interest to many of us, but for example, machine learning is a lot of number crunching. Anything that deals with images is a lot of number crunching. There's often stuff where you have like images, for example, often you can just treat each pixel individually. You just go over the image, which like 4,000 times 2,000 pixels, like 8 million pixels, and each of them you deal with individually. This is great. Like you can basically, if you can do 16 computations at once, there's a chance that you can roughly cut your computation speed into a 16th, which is pretty impressive. So this is probably something that most developers will only see under the hood and not deal with themselves. Now let's turn to the other stuff that Panama is doing, and that's foreign APIs. This is dealing with two different aspects of non-Java controlled stuff. So one of them is you don't want to have Java or Java garbage collection to control your memory. You want to put stuff off heap for whatever reason. And you can either use the byte buffer for that, but that's limited in size and it's somewhat inefficient, or use unsafe, which is unsafe and not supported, so you probably shouldn't. So you have this decision to make: do I do the right thing that is like limited and maybe slow, or do I do the wrong thing because it could turn out to be unsupported, like it could like change very soon, and I have to rewrite my code? You have to make this decision. That's not great. And the Java native interface that you use to call into foreign code, so this is about not Java memory and this is about not Java code, that also doesn't work great. It also works, but it's not great. Mainly is like it involves a couple of complicated tool chains that you have to deal with. And the reason why these are related is that if you want to call into native code to have it do some computation, you likely want to give it some data to work on and want to pull the data back into your program later. And you cannot give it data that is controlled by the garbage collector because the garbage collector might shuffle things around. So you have to put stuff off heap, tell your native code, there's the data, do the computation, and later you have to pull it back in. That's why these are related. And now, Panama offers two specific APIs to deal with that. The first one is the foreign memory API that gives you not just a byte buffer, but a bunch of classes to deal with this, to allocate memory, to access and manipulate memory. It's much smarter. You don't have to do that much offset computation. It's much safer to write code that works across different architectures. And in the end, you also have control to deallocate memory, which is also a problem with byte buffer. Byte buffer is just a single object, small one on heap that's like barely any memory, but it could reference like 2 gigabytes off heap, which means when your garbage collector thinks like, oh, we're under pressure, we don't have enough memory, it will not prioritize byte buffer. Like a byte buffer is like a very small thing. It could end up staying somewhere in some region of the garbage collector that doesn't look at because it seems small. But it references 2 gigabytes somewhere, and this will alleviate that problem. The foreign function API is a very low-level API. It uses method handles to call into foreign code, and that works pretty well. But the issue is that it's not really fun to write that. So there's a tool called JExtract, which you will point at a C file, and it will generate this low-level Java API for you. And then you can write proper Java code that interacts with that low-level API in a way that, that makes sense for you and that you can expose as a meaningful API. And the good thing about that is, when the C file gets updated, because a new version is released, you rerun JExtract, and then you get a new generated API, and then your API on top of that gets all kinds of compile errors because maybe things changed, and then you can deal with those in Java land with all the tools that we're used to. This time I don't have to guess. These two APIs were incubating separately, but they will now preview together in Java 19. That's already decided, that's already merged as far as I know. That's about the foreign APIs. The vector API is also very mature. It's already like in its, fourth preview. It's pretty stable, but it needs to wait for Valhalla because once we have whatever Valhalla promises, I'm going to go into that next, it will change. And that change would be backwards incompatible. And instead of finalizing the API now and then a year later we're stuck with something that's already outdated or we have to make breaking changes, the idea is it's probably going to stay in preview until Valhalla is ready, which is a bit unfortunate, but I think it's better to get the better end result. Once again, there's links to blog posts and videos on the vector API and all the foreign APIs. If this kind of stuff is interesting in you, like if you do anything with native, I can only recommend to check that out. Now let's talk about Project Valhalla. Its mission statement is super nondescript. Advanced Java, VM, and language feature candidates. Okay, that doesn't tell us anything. It launched in July 2014, and it's really a mammoth effort that Brian Getz and John Rose are working on here. And the motivation is to mend the split in Java's type system. In Java, we have primitives and we have classes. And everything that we create is a class. And all classes have two properties. They have identity and they are references. I'm going to explain in a second what that means. And we cannot create primitives. We can only deal with these things down here. So what does it mean to have an identity? If you create an int, so if you write int I equals 5 and int j equals 5, and then you wonder, are these the same 5s? The question doesn't even make sense. Of course, there's just one 5. Both ints are the same. They have the same value. And if they have the same value, they are the same thing. But if you write integer I is new integer 5 and integer j is new integer 5, then they have the same value, but they are not the same object, right? So they're different objects. That's what identity is. Identity means beyond whatever values are equal or not, things that have equal values can still be of different identity. And then also everything in Java is a reference. And now this has a bunch of properties. So everything, as I said, all classes that we create come with identity, and that means they have to have extra memory for the header that the JVM needs to track. That allows mutability, but also it makes everything mutable by default, which is not great. It allows locking and synchronization, all of that. And some of that we use much of the time, but definitely not all of the time. And they're just, sometimes you just want to write types that don't have identity. We don't care about that in certain situations. And similar for references. Every class comes as a reference, and that means it's always a memory indirection, right? That's the main reason why when you're dealing with, like, you know, let's say you're running a game and you have like two-dimensional points that you want to manage. What you don't want to do is have like an array of points, then every x and every y coordinate are like somewhere in memory, you don't know where, and you have to have this array of pointers that point to your points. Maybe not the best example. And you're just chasing all these pointers, right? You get cache misses, that takes a lot of time. That's why people who write like high-performance code like that, they would have like an array of x coordinates and another int array of y coordinates, which is not the code you want to write. Maybe it's the code that you have to write for performance reasons. So this memory access indirection isn't great. It also gives you nullability, which sometimes is great and sometimes isn't. And we're not going to talk about tearing. I just want to have that here for completeness sake. So now Project Valhalla comes in and says, okay, we're going to do a couple of things. We're going to give you value types which don't have identity. But beyond that, we're going to give you primitive types which also don't have identity, but also don't have, aren't references. So this is interesting because for the longest time, Valhalla just proposed one of these types. The idea was we give you value types and then they don't have identity, and then there was long discussions about are they references or not, and some types need that behavior and some types need the other behavior. And so that's why the decision was made, no, we're going to give you two types so you can pick. But they're very similar, we're going to see that in a second. And then there's the proposal for universal and specialized generics. I'm going to talk about that when I get to that. Okay, so let's start with value types. This is what this is likely more going to look like. You can write a regular class, which is a rational number. It's a nominator and a denominator. You write a constructor, you write accessors, equals hash code. You can implement interfaces, add additional methods. You can basically do whatever you want. But because it's a value class, all class and fields are implicitly final, and you cannot have all kinds of superclasses. But those are the only limitations. Other than that, you can do whatever you want. That's a value class. Now, a value class does not have identity. That's the deal here. You give up identity because you don't need it. So that means some runtime operations can throw an exception. You cannot lock on an object that doesn't have identity. So if you try to lock on it, you will get a runtime exception. And this identity check with the two equal signs, that doesn't make sense. It doesn't have identity. So instead it compares by state. It compares the fields, whether they have the same content. And the benefits we get from that is guaranteed immutability, which as someone who tries to write more functional code is pretty great because you don't need to worry about that anymore. And it's even more immutable than final, right? The problem with final fields is that technically you can use reflection to reset them, so the just-in-time compiler cannot optimize them as hard as it wants to because they technically can change. These one won't be able to change, just like the record ones, by the way. They're like super final, so to speak. It will be more expressive, the language. You can finally say this is a value, period. You don't have to, like with records, you don't have to go through, telling your colleagues like this is what my intention was with this type. No, it says value class, it's a value. But maybe one of the most obvious and important benefits is that the JVM will now be able to get much more extreme with optimizations because it does not need to track the identity of this object. But value types are still references. You still get null as a default value and you still get protection from tearing. And there will be migration to this. So the JDK has many value-based classes, such as optional and local datetime, and we plan to migrate many value-based classes in the JDK to value classes. That's important because that means that some of the things that I said that you cannot do with a value type, like they can throw exceptions when you lock on them, that's something that happens to optional then as well. Locking an optional will throw an exception. And you might think, wait, isn't that backwards incompatible? Now suddenly locking an optional will give you, well, no, because since Java 8, the Java doc for all of these types says, I'm a value-based class. That's usually like the last line of the Java doc for all of these types. And value-based is a link to another Java doc page. And that Java doc page gives you a number of things that you shouldn't do with these types. You shouldn't synchronize on them. You shouldn't rely on their identity, all of that. Because back then, Valhalla started in 2014. When Java 8 came out, there are already ideas what this is probably going to look like. So that's why the limitations are already in Java doc. But maybe make sure that you're actually abiding by these rules. Beyond that, we get primitive types. A primitive class looks very much like a value class. You can do almost all the same things, except you cannot reference your own type. So if you have a node in a linked list, and you want to make it a value type, sorry, a primitive type, then you cannot have a field of name node. The reason for that is that in memory you're supposed to have these like, they don't have references, we get to that. So in memory you have, like if you have a complex number like this, you have two longs in memory, that's it. Like nothing else, there's not a pointer. And if you have two longs, but then the complex number is supposed to know another complex number, then what, you get like two more fields for two more longs? But what if that complex number also knows another complex? So you cannot decide anymore how to embed this. That's why this limitation is there. So primitive types, just like value types, don't have identity. They also don't have references. That means they cannot be null. That means you need some kind of default value. And that default value is the default value of their fields. And that could be a reason to have a value class instead of a primitive class. Because if you create a primitive type like this one, that's great. Because if this doesn't have null as a default value, the default value will be 0 rational and 0 irrational. And that's a meaningful complex number. It's 0. That's great. But the other example I showed you was a rational number, a nominator and a denominator. And if the denominator is 0, you have an illegal number. So it's really weird to have a numerical type whose default value is an illegal value that you cannot compute with. So you probably don't want to do that. You probably want to be safe to say, okay, no, we need null as a default value here. That would be a main driver in deciding whether you want to do value or primitive class. Right. So we don't have null, and we don't have protection from tearing. Again, we're just mostly for completeness sake here. The cool thing about this is that the just-in-time compiler will be able to optimize this to the point where this is like comparable or even the same as today's primitives. So we will be able to write a type like the complex number that I just showed you and have it compute as fast as if you would put primitives everywhere. I'm going to skip this part because, again, 6 PhD theses times 4, so 24 and 45 minutes is a bit of a rush. So this is about, well, we have int and integer. Probably we need something similar for primitive types. The answer is yes, and this is what these slides go into. I'm going to skip them. Let's get to universal generics. So now we all start creating our own primitive and value types. Like in the past, it was already bad enough that you could not write like array list of long, for example. That was already bad enough. But there were only 8 types that you couldn't put in there, so we could live with it. And those are also pretty stupid types, right? Like a long, you usually want to have more complex business objects. All of that wasn't great, but it wasn't a big deal either. But now we all start creating our own value and primitive types, and that doesn't work either. That would be strange, because then as soon as your code touches generics, you have to go back to objects. That's not a thing you want to do, or to regular classes. So universal generics promise us you will be able to use primitives, but also your own value and primitive types as a generic type parameter. And this split in the type system, which made it all the way to generics, can now be healed, and we can now start using all of these types everywhere, which is a big change. Now, what this doesn't give you yet is the performance you would hope for with that. That's where specialized generics come in. Because so far you can only express that you want to have an array list of int, but what you don't want to have is an array list of int that is still backed by an object array. It would work, but it wouldn't be the performance that you want, right? If you have a primitive class of complex number that you created, and then you put them into a list, an array list, you still want to have the embedded longs, right? You want to have like rational, irrational, rational, rational of all of these complex numbers behind one another. You don't want to have pointers again. That was the whole, point of this. I really have to come up with an example. So yeah, so specialized generics promise that this array list of int will actually be backed by an int array. And I'm pretty sure that out of those 6 PhD theses, 4 of them are in here. That must be terribly complicated to get all of that into the JVM without breaking anything from the past. And so that's a major part of the effort. So what all of this will give us is fewer trade-offs between design and performance. You can now create the design that you want and then get the performance that you desire. You don't have to manually specialize code. We usually don't do that, but we've probably used in-stream or long-stream. Maybe you've used a toInt function. Maybe you have used Eclipse collections, which have these primitive specializations. All of that, what they do is, because Java generics or primitives don't work, they don't specialize, you do it manually. You go into basically, it's not all that Eclipse collection does. They do more in those int lists, for example. But basically an int list is take an array list, replace all reference to the generic type with int, and there you go. They do more, but that's like the basic understanding of what's happening there. And that's horrible. That's like, Eclipse collection has like megabytes of bytecode that come out of that generation. They don't write that manually, by the way. They have metacode that generates that. In-stream, long-stream, float-stream, sorry, double-stream, float-stream doesn't exist. I'm pretty sure that float-stream doesn't exist because somebody was like threatening to quit. Like, if you make me write one more specialization, I'm going to go. And it's like, okay, let's not have float-stream. That is not that important. It's the only reason I think that isn't there. It will get you better performance. As I said, you can express your design clearly now because you can say this is a value type. And I hope that this will lead to more robust APIs. Because one of the challenges, I think, in Java, which large projects specifically, is that you hand around mutable stuff. And then different subsystems reference the same mutable class, and then or instance, and then somebody changes one, and then the other subsystem didn't get hold of that. I think that's a common driver for subsystems that fall out of sync and don't understand what everybody else is doing. If our APIs mostly use value types and primitive types to communicate, they're not mutable, and they can't be. You don't have to put in a special effort. They're that by design. I think that's going to be pretty great. So Java is going to become more expressive and performant when, well, this is the vaguest of these plans. Basically, I'm hoping that next year we're going to see a lot of that stuff preview, right? Also the other dates, they were all previews. So this is really like, pretty much at this point, the best we can hope for, and then we'll still take 2-3 releases probably until these features are finalized. Right? So this is not something that you're going to use tomorrow. But Java has been here for 27, 28 years at this point. It's 27, I think. So at some point it's going to be done. By the end of the decade, I'm pretty sure. I have a lot more deeper dives. If you're interested in this at all, like read these 2 documents. The State of Valhalla, the first 2, part 1 and part 2, they're great. Like they're really easy to understand. Well, not really easy, but you don't have to be an expert at all. For the third part is where you have to be an expert, which is why I couldn't understand it. But the first 2 are really good. So just if this interests you, go read those. They're great. Okay, before we go into the last project, I'm going to have a little ad break here to catch my breath. Because we're doing more, right? It's not just these projects that are happening. These are like the big ticket items. There's so much more going on in the JDK all the time. For example, APIs are improved and added. So these are a bunch of, well, like a small list of the things that happened. I want to go randomly. Let's talk about Unix domain sockets, for example. So if you have different services that run on the same machine and they need to communicate with one another, you're probably using a loopback device for that, which works, but it's a bit slow and it technically opens up a connection that somebody from the outside could use to break in. Unix domain sockets is a feature that only existed on Unix, but Windows Server, whatever version, also supports it now, and that's why it was now pulled into Java. This uses files instead of network device to communicate, which is much faster, and it's also safer because you don't open yourself up to the outside, and it uses file system permissions, which are very well understood by all of your sysadmins. So this is a great way if you have, it must be on the same machine though, if you have services on the same machine communicating to make this safer and faster. For example, and there's tons of stuff like that. We also make usability improvements all the time. The one that I want to point out here is the simple web server. So this presentation is a website, and it's running in Chrome, and the server that launches these local files is the simple web server. And there's a command now that's called jwebserver since JDK 18 that you can just launch, and it's super simple, right? It doesn't do anything fancy. You're not going to use it in production. It's just there for demo, for tests, for just to launch some files and see what's up there. We have great new tooling. Code snippets in Javadoc is something that I find really, really interesting. probably not many other people do, but I do like documentation. And then JFR event streaming, if you're trying to observe what the JVMs that are under your control are doing, then that's a great way to do that. Performance gets improved all the time at big and small items. Security as well, all the time. There's ongoing fixes all the time. Sean Mullen is in charge of that at Oracle, and he has a blog where he posts one blog post every 6 months, like clockwork. When the new JDK releases out, he lists like all the security improvements that are in there. Highly recommend to look at that when security is at all important to you, which it probably is. We're not just putting stuff in. Stuff is also going out. Like for the first time since Java existed, there's a concerted effort to look at what it offers and decide which things are worth their weight and which aren't. So these are some of the things that are going out. So this is already removed. Master on RMI activation and concurrent mark sweep garbage collector are gone already, depending on which version you're on, right? If you're on 11, and we're going to come to that in a second, then this is not gone for you yet, but it will be. So be aware of that. And there's a bunch of things that's deprecated that will be phased out over the next years. Some of them sooner, I want to say these probably sooner, and security manager will probably take a longer time. So how do you prepare for this? Like if you want to use all these new features as soon as they come out, the best way to do this is to make sure that you stick to supported and standardized behavior. Make sure that you don't just rely on an implementation detail that goes for your dependencies as well as for the JDK, so it's easier to update. Stick to well-maintained projects that frequently update and deliver versions that work on the new Java releases if they have to change. Most don't, but some do, and then it's good to know that they're maintained. And try to generally keep everything up to date. I know it's very easy to put a bullet on a slide that says keep everything up to date. I know it's harder in practice, but it's really worth the effort for a lot of reasons. Like if you do it regularly, it makes it easier. It makes it easier to stay safe. It makes it easier to get like the new toys to play with, to get new performance improvements. So it's really worth the effort. If you want to find out what's going to go away soon, use JDepreScan, which is a command line tool that you can run over your jars on the jar of your dependencies as well, and it will tell you all of these things that you're using are deprecated. And try to build on each release, including early access. So try to build your project as it is now on 18 and 19 early access as well. Doesn't have to be on every pull request, right, or every commit. That's unnecessary, but at least like a nightly build. And if you know that out of your 3 projects, one of them doesn't compile on or doesn't work on 19, whatever, then don't do that one. If the tests don't pass, just compile. But make sure that you build as much as you can on the most recent release, including early access, so you find out as soon as you can when things change. They don't change a lot, but they do in some, like I showed you the slide earlier, right? A little bit changes, and it's good to find that out as soon as possible. And if you do all of that, it will be much, much simpler for you to get up to new release and use a new version. Okay, let's talk a little bit about that. So who here, by a show of hands, who here runs a JVM in production somewhere? That should be probably pretty much everybody, right? Yes? No? Okay. So who of that has like Java 7 or before? No matter the size of the crowd, there's always one person. Oh, right, sorry. I didn't phrase this correctly. I want to ask about the newest JVM that you run in production, because it's tough, right? Many have like several projects. So what's the newest JVM that you run in production? That also 7? Or? Great. Okay, so who's on 8 then? As the newest JVM that you run in production? That's a bunch of people. Who's on 11? 11, great. So that's my first bullet. Oh, that was the wrong button. There you go. Java 8 is slowly but resolutely overtaking 8. I mean, you're a self-selected group, right? But from the people that I talked at other conferences, it's always the same. At the moment, 11 has like double the share of 8. But there's probably very few people who know more about or more interested in recent Java versions than you sitting here right now. So it's not representative, I understand that, but it's good. So who's on 17? That's fewer than usual, but it still looks somewhat good in this crowd, not quite that much. Of those who are on 11, who thinks they will still be on 11 like in 6 months? Well, okay, so let's ask the other way around. Of those on 11, who think they will update to 17 in the next 6 months? That's most. That's pretty good. Yeah, we've seen that a lot. Like 8 to 11 can be challenging. 11 to 17 is very easy for most people. Now, I probably shouldn't ask, but who uses 18? Somebody save me? No? Damn it. Okay, so in a large crowd, I get a couple people usually. Okay, now I want to talk about Project Loom. I got 5 minutes left for that. If after that you have any questions, I'll still be around here a bit. You can always ask me. I won't have time for questions here because I have way too many slides anyway. You can find me on Twitter
I'm nipafx. It says down here actually. Ask me if you have any questions. Find me somewhere. I'm on Twitter. I'm here. I'm on GitHub or whatever. I do a Twitch stream. Just find me and ask. I'll gladly answer all your questions. Okay, let's talk a little bit about Loom. And the motivation for Loom is something like this: a very simple web request that comes in. You parse the JSON or whatever. You create the database with the blocking call. At some point, you get the response back. You parse all of the data, put it into whatever response you're sending back, and that's that. It's a very straightforward problem. The resource utilization for that generally is great for steps 1 and 3, and is horrible for step 2 because you're sitting there doing nothing. So how would you implement that? There are two competing approaches. One of them is a synchronous approach, which is straightforward and simple, right? So you get different concurrent requests, so you use different threads to serve them. You use one thread for each request. The code is simple to write, to debug, to profile. But the problem is it blocks the thread on certain calls. And platform threads, meaning the operating system threads, they are expensive. Like you can have thousands, but you probably can't have hundreds of thousands or millions of them. And they might become the limiting factor. Not how fast the database is or how fast your CPU is. No, how many threads can you afford at the same time? That can be the limiting factor, which will lead to lower throughput than all the other resources would allow for. So that's where asynchronous programming came in. They came with a radical idea, which is, let's only use threads if we need them. So, okay, now how do we do that? We use non-blocking APIs, which like futures or reactive streams. The issue with that is it's harder to write, although I think that can probably be overcome, but it's also challenging to debug and profile and to understand what exactly is going on in a request. It's also largely incompatible with synchronous code. If you use a library that doesn't understand what you're doing and it starts blocking these threads, you're back to square one. That isn't great. But they do share platform threads, and that's why this is there. So it gives you much better resource utilization and hopefully a higher throughput. And once again, there's a conflict. We've said this a couple of times today. There's often a conflict between what you want to do and what you feel like you have to do for another reason. And resolving these conflicts is something that many of these projects are concerned with. And this one wants to resolve the conflict between simplicity and throughput. And this is where virtual threads come in. A virtual thread is an instance of the class thread. It is a private subclass, but it's an instance of the class thread. But it has very low memory footprint, so instead of about a megabyte, which is what a regular thread has, it has like kilobytes or just bytes even. Has very small switching costs, but the most important part is it's scheduled by the Java runtime. So the operating system who's in charge is the Java runtime who's in charge. And when you're waiting, you don't need an operating system thread. That's like the above the surface thing that you need to know. Now let's look below the surface, let's understand how this is implemented. At least like on a, still on a high level. The idea here is that virtual threads run on a pool of so-called carrier threads. So you can have millions of virtual threads, but you just have like a limited number of carrier threads which are doing the actual computation. But the thing is like when a virtual thread would do something that's blocking, the runtime will just say, okay, you're blocking. No, you're not blocking. You're just taking the virtual thread, which thinks it's blocking, and takes the carrier thread and lets that do something else. And then later it can continue. So if we talk through this request, this is how this goes. The request goes in, and the runtime submits the task, which is interpret that request, to the carrier thread pool. And at some point, a carrier thread will pick it up, will do it, and when it blocks, the virtual thread yields, and the runtime takes the carrier thread, puts it back into the pool, and it can then do the same thing for somebody else. And when the second step unblocks, and you get your data back, it resubmits the task, and task 3 will be done. So, for example, this is super useless, but still very impressive. We have a range of creating 1 million virtual threads here, and then they all sleep for a second, and this works. Like, I do not recommend to do that with platform threads. You will not want to create 1 million of them unless you have a long time to wait until your systems can react to anything again. But with virtual threads, it's not a problem. It's also pointless, but it's pretty impressive. What's more likely what you want to do is you can just create. There's a specific executor that allows you to create new virtual threads because they're so cheap. You just, you don't care about creating new virtual threads. You have 2 things you want to do at the same time. Just create 2 virtual threads and let them do that. Okay, I'm thinking I'm running out of time. I just want to give you a quick thing about virtual threads are not faster, but they will give you better throughput. They will not make one computation from start to end shorter. They will allow you to do more of those at the same time. That's a critical understanding. And their cheapness will also allow you to use a new concurrency programming model that's called structured concurrency, which we also want to skip. If you want to, as I said, if you want to meet me, I'm around. I'm nipafx on all the platforms, also a website, nipafx.dev. As I mentioned, I work for Oracle, so we create 2 websites, Inside Java and dev.Java. They can all recommend to check out. Inside.Java is for the people like you who are interested in current developments, what's going on, what does happen with these JEPs. And dev.Java is maybe for more junior people, just as like a module system tutorial and everything. Talk about the module system. I also wrote a book about that, but nobody cares, I know. But if you do care, it's a good book. And that's it. Thank you very much.
Thank you, Nicolai.